Okay, so this video is both for lessons 4 and 5. We're going to be graphing inverse variation functions. And so we've talked a little bit about this in the activity that we did in class the other day, but let's go ahead and start with just a simple graph like this. We talked a little bit about this also when we talked about graphing inverse functions. I can, for this one, maybe just set up a little table of values. If I have, let's say I let x equal 1, 9 divided by 1 is simply going to be 9, and that's going to be the point at 1, 9, which is right up here. Another easy point to plug in is 3. If x is 3, then 9 divided by 3 is 3, and I have a point here. Could let x be 9, and then 9 divided by 9 is 1, and so I'm going to be at a point at over 9 and up 1. And I could plug in other points there, but what we're going to see is a graph that looks something like this. It's going to approach the y-axis going in this direction, but it'll never touch it. It'll approach the x-axis in this direction, but it'll never touch it. Could also make all of these numbers negative. If I took 9 divided by negative 1, I'd get negative 9. 9 divided by negative 3 is negative 3, and 9 divided by negative 9 is negative 1. So in other words, I'll have the point at negative 1, negative 9, which is here, at negative 3, which is here, and then at negative 9, negative 1, which is here, and I'm going to have another part of this graph that goes in this direction. We can put dotted lines going along the x-axis and the y-axis because those represent asymptotes that these graphs will approach but never touch. One of the things that I think is helpful is to find this middle point and this middle point. And the way to find that middle point, that's the 3, 3 point, or the negative 3, negative 3 point. That's simply the square root of the k value. And so if we just find that point and then graph our asymptotes, then we should be okay just kind of eyeballing these graphs to get them close to where we want them to be. Let's try that again with a k value of negative 16. Again, I can make an x and y chart here, and if I plug in, let's say, let's go with 8, then negative 16 divided by 8 is negative 2, so I'm at over 8, negative 2, which is here. I could plug in negative 4, or let's go with positive 4 first. Negative 16 divided by positive 4 is positive 4, so I'm at the point, or is negative 16 divided by positive 4 is negative 4, and so I'm at over 4 and down 4, which is this point. And if I plug in 2, negative 16 divided by 2 is negative 8, so 2 negative 8 is this point right here. I'd have a point at like 16 negative 1 and 1 negative 16, but we're going to have a hyperbola that looks like this. Notice because it is negative, we're not in the first quadrant anymore. We've reflected that over the x-axis, and we are now in the fourth quadrant. Same thing goes if I made all of these numbers on the x value negative, then all the y values would end up being positive, and I'd have a point at 8, negative 2, or negative 2, 8, negative 4, 4, and negative 8, 2, and I would have another hyperbola here. And again, I have these lines here that are my asymptotes that are the x-axis and the y-axis. Again, probably the most critical point is this point right here and this point right here. Because it's the 16, I'm going to go over 4, and usually I would go up 4 to be here, but because it's negative 16, that's going to be reflected over the x-axis. And the one that's normally down here at negative 4 is reflected over the x-axis also and is up above. So if we are graphing something that's y equals k over x, we know that it's going to be in this form here, where the hyperbolas are in the first and the third quadrants. But if I have y equals negative k over x, that's a k, then the hyperbolas switch and they're in the second and the fourth quadrants on our graph. Let's take a look at one more. This doesn't look like an inverse function, but if I solve for y, I'm going to get x by itself. So I'm going to divide by x. I'll have y equals 6 over x. So I could make a table of values for this one. I could just get the square root of 6, and the square root of 6 is 2.45 roughly. So what I'm going to do to graph this is I'm going to go over 2.45 and up 2.45, which is close to here. And that's the only point that I really need, as long as I know that my x and y are the asymptotes. I'll also go negative 2.45 and negative 2.45. I'll plot that point, and my graph's going to look something like this. probably a good idea to put the asymptotes on the graph, even though they're probably going to be covered up right now with the x and the y axis. We're going to be shifting these here shortly. So let's take a look at another graph. Again, this doesn't look like an inverse function. Let's see if it is, though. If I subtract 4 from both sides, I'll have 2 times x times y equals -4. If I divide this side here by 2x, I'm going to divide the other side by 2x. I want to get y by itself. So y is going to equal -4 over 2x. Well, that's the same thing as -2 over x. And so I'm going to take the square root of 2, which is about 1.4. So I'm going to go 1.4 over and 1.4 down, which is about here. And I'm going to be in the fourth quadrant because it's a -2x. I'll do the same thing in the third quadrant, 1.4 to the left, 1.4 up, and I'm going to have something that looks like this. Hopefully we're getting the hang of this. Some of the time you will see, normally we like to see it in this form, but if we have something that's in this form here, 3 over 5x, I just want to show you that that's the same thing as 3/5 divided by x, which means the k value would be 3/5. Why is this the same? Well, this means here that I'm going to take 3/5 divided by x. Well, when I divide by x, that's the same thing as taking 3/5 times the reciprocal of x, which is 1 over x. So when I multiply these together, the 3 is on top, and then on the bottom I have the 5x. And so what that means is that if I have 3 over 5x, that's the same thing as writing as 3/5 over x. And so we can find the k value of 3/5 and graph that equation as well. Okay, so now what we're going to do is start graphing these inverses, but they include shifts. So they're technically not inverse functions, but they're very similar to it, although we're going to be just, in this case, shifting every point up 2 units. Let me graph the normal graph here. If I was just graphing y equals 4 over x, we know that it would look like this. I'd have an asymptote here. I'd have an asymptote along the y-axis. Because the k value is 4, I'd go over 2 and up 2, and I would have a graph that looks something like this. I'd go over left 2 and down 2, and it would be a graph that looks something like this. This is more what you're going to see in assignment number 5. But because I'm adding 2 to all of those units, I'm going to take all of the y values, and before I make them y, I'm going to add a 2 to it. So what I'm going to end up having on my graph is all of these points are going to be moved up 2 units. The asymptote is going to be moved up 2 units. The vertical asymptote is going to be moved up 2 units, so it's like my origin is now at the point 0, 2. The rest of my graph is still the same. From here, I'm still going to go over 2 and up 2. This point here would slide up 2 units here, or I could go left 2, down 2 from my new origin. And I have the exact same graph that I had before that was in blue. The only difference is now it's in red and it slid up 2 units. And so the graph of this function is the red function. Let's take a look at this graph here. This is the same kind of thing. I'm going to graph a parent function of this one first, which is 1 over x. So if I were graphing 1 over x, I'd have a point at 1, 1, and it would look something like this. Also graph a point at -1, 1, and it would look something like this. And so the same thing is going to happen here, except this is going to be a shift. It's not going to be a shift up, though. In order to get my point at 1, I'm going to have to plug in a 3 for x. So normally in this graph, I would just plug in a 1, and I'd go up 1. But now I'm going to have to plug in a 3. And so now if I plug in a 3, actually I'm going to plug in a 4. 4 minus 3 is 1, and then 1 over 1 is 1. So instead of this point being here at 1, 1, it's at 4, 1. And you can see it's shifted over 3 units to the right. Well, that means the entire graph is going to be shifted over 3 units to the right. Here's going to be my vertical asymptote. Here's my horizontal asymptote. and I'm going to have a point at 1, 1 and negative 1, 1, and then I'm going to draw my hyperbolas, which looks something like that and something like this, and my graph is going to be the blue graph. And what this did down here is just shifting it 3 units to the right. So when we graph these equations, it's going to be k over x minus h plus, normally we would call this k, I'm going to call it w for right now. It's a vertical shift. This moves it up and down. This down here, the h moves it back and forth, but opposite of what you might think. An x minus 3 moves it to the right 3 units. So let's take a look at something like this. I'm going to graph this entire equation, and I'm not going to graph the parent function first. I'm just going to go ahead and shift it 2 units to the left and 1 unit down. So 2 units to the left means my asymptote, my vertical asymptote, is going to be 2 units to the left. My horizontal asymptote, which is normally along the x-axis, is now going to be shifted 2 units down, or 1 unit down, so it's going to be right here. So this is like my new origin here. And so what I'm going to do now is my k value is negative 9. I'm going to go 3 units to the left and 3 units down, which is this point. And I'm going to go 3 units to the left and 3 units up, which is this point. And you can see that's what my graph is going to look like. And that's what the graph of these inverse functions look like. This is what assignments 4 and 5 are over. And so the first assignment, assignment number 4, doesn't have any shifts involved. And then the second assignment is shifting these graphs along the coordinate plane. That's what our homework assignment is. Good luck on that, and we will see you tomorrow in class. Oh, I do have one more. So if I were to do this one, this doesn't have any shifts, but the k value is 3/4 over x. So I'd take the square root of 3/4, and if I do the square root of 3/4, that's second square root of, that's 0.86. So I'd go 0.86 to the right, 0.86 up, and it would look like this. 0.86 to the left, 0.86 down, and it would look like this as well. So anyway, we'll see you tomorrow in class.